This video is going to guide you step by step through solving the MyMatrix exercise. So the MyMatrix exercise, if you take a look at the requirements, you are going to find already all of this code already written for you, okay? So we're going to start by having a quick overview of what's in this code, okay? And then we are going to focus on the one method that we need to write. So the code that is given to you contains a class, a public class, MyMatrix, okay? And inside that class, 1, 2, 3 methods, all right? So the first one is actually the one which implementation is currently incomplete. So that's going to be our job to implement this method and actually put code here that does a little bit more than always returning true. So the object of this method, named isMatrixSorted, is to actually test if a given two-dimensional matrix of int value that is passed as parameter here under the name data, to test if that matrix is actually in order or not. Okay, and by default, we are told to use the ascending order, right? So this method is going to look at the matrix passed as parameter, determine whether all the int values in it are in order. So ascending order means that, for example, if we have multiple rows of 5 elements, the first row would be 1, 2, 3, 4, 5. So here's an example here of a row that would be in order. Then the next row is going to start at something that's bigger than 5, right? And go 6, 7, 8, 9, 10, for example. And then the next row starts at something that is bigger than 10, for example, 11, and goes in order 11, 12, 13, 14, 15. So the numbers do not have to be consecutive, but we have to have an order, right? And this is the order is left to right, row per row inside the matrix. So that's what we want to detect on an arbitrary matrix that is passed as parameter to our method. And then depending on whether we find that this matrix is already in order or not, we return true or we return false. And as you can see, the default implementation is very optimistic. The default implementation returns true all the time. So we are going to fix that, okay? We're going to replace line 11 by a little bit more code that hopefully is going to detect whether any arbitrary matrix is in order or not. And then we have two other methods in this class. Those two methods were actually given to you. The first one is a main method, okay? The second one is a run test method. So let's start with run test to explain what it is all about, okay? So public static void run test. So this method first is a void method, so it doesn't return anything, okay? It doesn't return any value, but it takes two parameters, a string named MSG, message, and a Boolean result. So what are those parameters going to mean? What is the semantic? Well, the string is just a message that we want to display that's going to let you know what this particular test is about. And then the Boolean result is going to be the result of the test. The result of the test is a Boolean because it can be either true, which means the test was successful, or false, which means the test was failed. Okay, so this is what this method does. It only actually, it's kind of like a pretty printer. It only displays a nice little message formatted as the way that we want it and allows us to say pretty much the test succeeded or the test failed. Nothing more. So let's take a look at the implementation. Since I mentioned, that this method is pretty much just there to do some pretty printing on the screen, it uses system.out printf, okay, which we have been already using elsewhere in this course. It displays the words testing, a tabulation, then between square bracket, we are going to put here a string formatted in a specific way, left, centered, etc., in a window of 30 characters. So if you give me a message here that is bigger than 30 characters, it's going to be automatically truncated so it fits in that window so that everything aligns when we display it. All the test results align neatly. Then we have a tabulation and a row, another tabulation, and another string here, %s. So the first string we display here, okay, with all this formatting, is going to be the message. The second string that we display here is given to you by this ternary conditional operator. We look at the Boolean result. If the Boolean result is true, then the test was successful. We display the message shiny. If the Boolean is false, we display the message failed. okay? And that's all this little method is going to do for us. So we go back now to the main method here. So traditional public static void main method takes an argument that is an array of strings. These are like the command line parameters, okay? We're not going to use those in this exercise. And then we have a little bit of code that was given to us in the requirement. And this code is actually defining a few arrays, okay? So here's an array here named MSG, messages, and this array is an array of string. It contains currently 2 strings. So these are the messages that we are going to then pass to the run test method here, okay? So one message for our first test, another message for our second test. Similarly, we are going to store in an array of 2 booleans the expected results of calling isMatrixSorted, the method we are trying to write, on those 2 different tests. Okay, so the expected result on the first test will be true, so we'll make sure to pass a matrix that is already sorted. The second expected result will be false, so we will pass a matrix that is actually not sorted. So we have talked about, you know, the message we want to display for every test. We have talked about what we expect the result of applying isMatrixSorted on each of the matrix corresponding to each of the tests will be. We have not defined the matrices yet. So here's one 2-dimensional matrix of int value named test0. So that's our first test. And I use here the block initialization syntax, okay, to specify all the elements of my matrix. So I declare the test variable, reference variable. At the same time, I ask Java to create an object of type, you know, 2-dimensional array and populate it with the value that I specified in my block initializer. So you can see that the syntax, we have covered that already in the reading assignment, right? The syntax is simple. This is the first row of the matrix between curly braces, each element separated by comma, and then we put a comma because that's the first element in terms of the rows, right? So this is the first row, comma, separated from the second row, which is itself, you know, a series of elements between curly brace, and then the third row, which is also a series of elements between curly brace. And as you can see in this example, everything is in order. So the first row goes 1, 2, 3, 4, 5, the second 6, 7, 8, 9, 10, and then 11, 12, 13, 14, and 15. So we have a sorted matrix which corresponds to what we expect isMatrixSorted to tell us, and which correspond to the title, if you want, the message that we put to describe this test. And then we said that we would have a mixed up matrix that's going to return false when we call isMatrixSorted with it as parameter. So let's take a look at it. Same syntax here. We define a second variable test1. And this time you can tell from the get-go, right? 5, 3, 2, 1, this is not in order. This is not in ascending order. 5, 3, 2, 1, 4, it's not even in descending order anymore. And then we keep going like that in each row. Everything is mixed up, okay? So clearly, isMatrixSorted should tell us that this is not a properly already sorted matrix. So we have a result that returns true, a result that should return false, okay? And then we're going to use our method. So here's how we use our method in conjunction with runTest. And we could write each of those 2 lines, line 23 and line 24, we could write them on several lines, okay? But I kind of adopted a compact notation here. So I'm calling runTest. Like we said, it's just a pretty printer, right? So here's the message that I wanted to format and display for me. The message corresponding to the first test. And then, remember the Boolean that was supposed to be true if the test was successful and false if the test was a failure? Well, here it is. This is how I'm going to compute that Boolean. I'm going to call isMatrixSorted, my method, on the first matrix, the matrix for the first test, test0. And then I'm going to compare whatever value is returned by isMatrixSorted to what I expected to find as a result value for that test. So that I'm going to find that in the expected index 0 array. And that's it. That's all there is to it. So this line here, line 23, is going to make the first call to isMatrixSorted, check that the return value is what we expected in our test, and then use runTest to pretty much display on the screen nicely, neatly, the result of that test. Line 24, once you understand line 23, line 24 is not going to hold any surprise for you. We are doing exactly the same thing for the second test. So the message for the second test is at index 1 in the MSG array. The matrix for the second test is stored in the variable test1. And the expected return value of is matrix sorted when called with that matrix as parameter is stored in the array, a Boolean array expected at index 1. So we do the same thing to actually validate that our second test is also working. So let's take a look. Let's compile this. It should compile. Okay, this is just straight from the requirement. All right, and now let's run it and see what we get. So the output is, you can see the formatting here. We make sure that we have 30 characters. If it's too long, we truncate. If it's too short, then we pad with spaces so that everything aligns perfectly. So testing an already sorted matrix, the test worked. Testing a mixed up matrix, the test failed. So we could say that 50% of our tests are working, so 50% of the job is done. Not quite, because really our implementation here is a cheat, okay? We return true all the time, so we'll be right, you know, like in this case, we'll be right for the already sorted matrix, but we'll be wrong for any sort of matrix that is not appropriately sorted. So that's it for this little video. It gives you an overview of what we had actually in the requirement. And the next video is going to focus on, okay, how do we write actually a is matrix sorted method that is worth a dime.